Hello. So, it's very hot out, so I'm trying to record in a local coffee shop. Um, Unfortunately, my pers I forgot my webcam and the document camera that I'm using now as a webcam is broken. If I don't hold it up, it does that. So I'm going to try to show the innovative can-do attitude that made America famous and prop the document camera up with a bottle of canola oil spray. Um, this may be the only video I record in this setting. It feels slightly ridiculous. But the idea of this lesson is a simple one. The topic of the day is one-sided limits. And the idea is simple enough. Let's take a function we're probably all familiar with. A of r equals pi r squared. So this is the area of a circle. The input is going to be the radius. The output is going to be the area. And if I ask for the limit as the radius approaches zero, this is a simple quadratic. It's a second degree polynomial. And to find the limits of polynomials, we can just take the number and stick it right in. So as the radius goes to zero, the area goes to zero. Probably not a great surprise to any of us. But there's something a little wonky going on here. When we talk about r converging to zero, in the limit, there's no assumption that r is to the left of zero or to the right of zero. R is just getting close to zero. But in the geometry of the problem, r is a radius, r is a distance, so r cannot be a negative. So we want to talk about r getting close to zero, but in this problem, we have an additional condition that has to be satisfied. R is getting close to zero, but R is always greater than zero. And situations like this are what the one-sided limits are for. If we write the limit as x approaches c of a function, but we put a little addition sign next to the c, we are asking, where does, or maybe I should say what number does f of x approach as x gets close to c with the condition that x is greater than c. And in the problem on the previous page, we were really looking at a limit like this. We were looking at the limit of the area function. We were letting r approach 0, but we had the additional constraint that r is greater than 0. And this is called the right-hand limit. For the pretty straightforward reason that if we draw a number line, if we're making the assumption that we're looking at numbers greater than c, then we are approaching c from the right-hand side. And this notion generates to the left pretty naturally. We can look at the limit as x approaches c from the left. And this is the limit, but with the additional constraint that x be less than c. As an example of this, probably not an example you'll see in your major. If you're taking physics, you're probably going to want the regular calculus sequence. But it's a result of physics, a result of relativity specifically, that objects' masses change with their velocity. And we can ask what happens to the mass function as the velocity function approaches light speed. But in day-to-day matter, maybe there are like tachyons or theoretical particles or whatever, but day-to-day matter is all traveling at speeds less than that of light. So we're approaching light speed, but there's an additional assumption that our current speed is less than the speed of light. So there's an example of a left-hand limit. And maybe the easiest way to get a handle on this, assuming you don't already have a handle on it, is to look at a piecewise defined function. That's that f of x be x squared when x is less than 0, and x plus 1 when x is greater than or equal to 0. So the graph looks like that. And let's ask, what's the limit as x approaches 0 from the left of f of x? Okay, if we're approaching 0 from the left, that means we're less than 0. If we're less than 0, we're in this piece. And we've got the limit as x approaches 0 from the left of x squared. And then just like regular limits, this is a polynomial. We can just plug the 0 in. And we find that the limit is 0. By contrast, if we're approaching 0 from the right, that means we're bigger than 0. And that means we're working with this piece. So we're taking the limit as x approaches 0 from the right of x plus 1, 0 plus 1 equals 1. We observe that the left and the right hand limits are different. And we end this video with a theorem or a remark or whatever you want to call it, that the limit as x approaches c of f of x exists. This is not a typo. IFF, if and only if. The regular two-sided limit exists if and only if both one-sided limits exist and the one-sided limits are equal. The limit from the left equals the limit from the right. I'm sorry you did not get to see my smiling face for most of this recording. I think I'm done trying to record in this way. I think I must brave the summer Nebraska heat and walk in and find a functional document camera. But goodbye for now.